And also for anyone online, please type in your questions on the online chat box, and we can take them. There actually is already a comment here. I'll go ahead and read it. So it's from Lindsay Soon. Comment to Brad for core 73001/2. We saw a slight increase in OMAT in the lower core toward the bottom, which might be due to mixing with the tiny amount of black glasses. That's all the comment says. I think it was given right at the time the presentation ended, so.
I would say, thank you, Lingsher, that's good.
Okay.
No, but I would note that the optical maturity that she determined was on a different dissection interval, I think, than the material that Dick Morris analyzed for isobesper FEO using FMR. So it could be that there was some variation, but we really saw no variation at all in the isobesper FEO.
Thanks. More questions? Anyone?
Could I ask a question? A question for Tara. So the talk went by pretty fast and I'm pretty slow. So if you showed compositions of the impact glass, the impact melt in TWAT 005, what do you recall? What was the composition? What was the iron content, for example, FEO, compared to the bulk FEO of the meteorite, which I think is pretty low, like between 3 and 4 weight percent?
Unfortunately, we've not been able to look at the melt within this sample yet. We mainly focused on this stage at mineral chemistry of olivine, plagioclase, pyroxene. That's something we would like to do in future to further test this and further test whether there is actually similarities to the bulk composition.
Okay, thanks. Good, I didn't miss it.
I have a question. I'm going to go all the way back to James's talk on endurance, right? Which seems like it was a while ago. So when we had the endurance science workshop, Bethany Ellman talked about the need to be able to go into a site where we might think there's a sample to get. And then we really have to do some kind of sitting and characterization of everything before we can go and look for the sample and the rest. When some of the simulations you're showing from JPL, where they're trying to get the rovers, they have to travel at a certain speed to get the place, is the idea that you would sort of zoom to a region and then you would stop and do that assessment? Or what's the thinking on how you would get a sample from that?
Yeah, so the current notional ConOps of endurance is that it's really booking it from one sample site to the next, and that sample site might be tens or even hundreds of kilometers away. Once it gets there, the idea was to use in situ instruments to help select the samples. I think the extent to which you need or want to use in situ instruments to select those samples is kind of an outstanding question for the SGT to tackle. I've been in discussions, right, on both sides where some have said, oh, you're not gonna want to waste time doing that because the moon's gonna be so mixed up, you're just gonna want to try to get as much as you can, as quickly as you can. And then others saying, no, you're gonna want to have your super high resolution instruments and really try to find the perfect sample. And there's a trade in there that needs to be done. I will say from the perspective of autonomy, this is actually something that Perseverance, which is albeit a very different rover, a very different sample collection approach, is doing partially autonomously. They have a system called Aegis, and basically as they drive along, they can take images, and they have software on board that decides if they see scientifically interesting things, oh, we're gonna zap it with the libs, do a scientific measurement. So there's already some precedent for using autonomy to help expedite science acquisition, but I think this is a good task for the SGT to tackle.
And just a very, very quick follow-up. You said that the SDT you said it's going to happen this summer? Or they're going to start having a call this summer? I saw that in your slide, but.
None of the NASA people are in the room. I mean, Ryan Watkins announced that it would be happening imminently.
Okay.
And that's, I have no additional information beyond that.
Okay.
So, soon,
Great, thanks.
soon trademark.
And Ryan's still on maternity leave, right?
Yes.
So this is a great topic. And if I might just ask James, your thoughts on, well, we've had this discussion, but thoughts from, lots of discussions about sample size and about sample type. And, when we proposed Moonrise, we were basically taking a scoop of regolith, but then sieving it to get rock fragments and trying to get, as coarse as you could, but there were constraints on size and mass and so forth. But, thinking about what you can do with samples of different sizes, is a centimeter big enough? Do you really want a baseball size sample, softball size sample? And then how much can you hold on the rover? So I don't know if you have any thoughts on these things, sample size, sieving.
Well, I'll say one of the takeaways from the science workshop was the entire engineering team came away saying, oh, we need sieving. We don't want to do just a shovel and scoop and trust on the statistics to get the right number of rocklets. Now, as for the actual size, I mean, I would throw these questions right back to you all, because I am not a sample scientist, about what the ideal size, number, mass, type of material you need to actually answer the questions are. Again, it's a lovely topic for the SCT to tackle.
Yeah, and I'll say this, I'm not a sample scientist either, but it seemed to be the outcome from the workshop from people like Paul Warren and others were saying that we probably need samples that are, I'm gonna say 5 centimeters, that would allow you to get a really good age date. And if you go to smaller samples, it's more difficult to extract a satisfying age sample, or if satisfying age from a very small sample. That was my takeaway, and you guys can argue whether that's right or not.
Well, again, it clearly depends on the lithology that one is trying to establish chronology with.
Yeah.
We're just starting to do some work on a ferrin and orthosite, which would be extremely difficult to do. And we're starting off with 3 grams, maybe 4 grams, just to do neodymium, samarium, rubidium, strontium, and argon. That has nothing to do with any other geochemistry, any other thin sections, or doing any other sorts of analyses on this. So those are kind of the sizes or the masses that one needs to do that. And of course, if one is finding some really interesting breccias, one perhaps would want something that is quite a bit larger than that, so one can place the breccias and the lithic fragments that perhaps are in the breccias, again, in some sort of context. So it's really dependent upon that.
Not only dependent on lithology, but also on the technique that you're using. So there have been some great advancements in the last decade in doing things like lead-lead analyses. And so if you have something that's a monomixed class, and it can be very small, if you have different areas of the breccia or areas of the matrix of a breccia that have different concentrations of, say, potassium or uranium-bearing species, then you can do that with lead with the ion microprobe. And you need, something that may be hundreds of microns in size in terms of a clast. And you can get a spot that's maybe 10 microns in size, and you get ages. So, this has been pioneered by Josh Snape and co-workers and Martin Whitehouse in the NordSIMS facility, and it's really some fantastic ages.
I was just gonna say, we probably should give questions to other speakers here, but this is fascinating.
Well, I just want to make one other
Yeah.
comment. Just in terms of chronology and ages, if Lars Borg was up here, he'd say, well, there's an age, but what does that date? Is it an event? And so therefore, sometimes you need a larger sample to better understand, place that age within some sort of geological context.
Yeah.
I'll give it to somebody else.
Okay.
This is for Olive. You mentioned you saw phosphates, potential phosphates. For the nano FTIR, what do you use as a reference database to identify the spectral features?
That's a great question. I mean, I personally have been referencing there's a new research faculty at my university who has done a lot of research on this particular on specifically Ryugu NanoIR, who's done a ton of research on this, and he would probably be better to kind of answer this question for you. And I believe he has a virtual poster, I believe, that he was presenting, but that's Mehmet Yeseltas. And he's done a lot of research with the NanoIR on Ryugu samples. And so I've been referencing a lot of his work as well as a previous a graduate student who worked with my advisor as well, Jordan Young, who has done a lot of work. So there's some publications that I've been kind of referencing to identify those in my work.
Okay, thank you very much. I'm going to go ahead and give one last question, and I think we're going to move on. So this is for Brad. You had a plot of the IS over FEO for that 17 core sample. Did your group do those measurements newly produced, or are those based off of some other measurements from a while back?
Oh, no, those were new. Those were done a summer ago by Dick Morris, the ISODES, and we did the FEO in our lab on the same aliquots. So Dick got the samples, did the FMR, and then sent the samples to us. We did the chemistry.
Okay, no, sounds cool. Yep. Just what kind of fascinated me about that was it looking, in my own work at the maturities of these soil samples. You get a lot of references to the 1978 paper by Morris et al. For all of those maturities, and that was one of the driving factors behind us doing the scanning transmission electron microscopy to actually see the nanophase iron there, because we couldn't necessarily find imagery like that for every single one of those soils. I think we could for 10084, and yeah, so anyway, it was just kind of neat to actually be able to see that, even though, the measurements have been done some time ago, and I know supposedly there's been some issues repeating some of that at times. But
Chip reminds me that I should say that those are brand new open samples. In other words, 73002 and 001 had not been opened. 001 had been sealed on the moon under vacuum and returned, and then kept in curation for 50 years.
Wow.
So
okay.
we opened those samples as part of ANCSA. So they're fresh samples and fresh analyses. And Dick he has a new instrument for FMR, and he went back and did a very careful cross-calibration with other samples that he analyzed in the past. So we feel pretty good about those numbers.
Okay, yeah, sounds great. Thank you. Okay, so
And those samples are available.
and they are okay. We'll keep that in mind. So with that in mind, we'll go ahead. There is supposed to be a group photograph taken out in the forum area there here soon. And on the original schedule, it was supposed to be done at 6 o'clock. However, I think everything's been pushed forward a little bit today. So with that, I think we will wrap up. Thank you very much for making this a great session. And thank you to all of our speakers online as well. Yeah.